Good morning, everyone. It's a real pleasure for me to be here and to present something about building materials and grey energy. But before speaking about grey energy and embodied energy, it's important to put this issue in a broader context in terms of sustainable development, sustainable architecture, and environmental impacts of the building sector. The building sector is a key sector in Europe on economical point of view, but it's also a major consumer in energy and also in natural resource. But it offers a great potential of improvement in terms of greenhouse gas emission, but also in use of resource, with a great potential of recycling. Choice of building materials is a fundamental step in the design process, and for two reasons. First, building material is the base, the material, the substance with which we create building, which we pass from an idea on paper to reality on the site, on a building site. Secondly, selecting and assembling materials to create building is a complex process based on variety of constraints and knowledge, and also on different scale of time and space. And this is why this is what the figure, on the slide here try to define. We have some subjective aspects for the perception of building materials, texture, color, odor, something. We have also very objective aspects with the technical properties, and we have also different changing aspects with the requirements: functional, urban, geographical, economic. It's a great impact in the building sector. And since 1987, we have two new requirements: health requirements and environmental requirements. It's also important to replace the choice of building material in terms of sustainable architecture. And in my research team, we try to define what is sustainable architecture, and we propose this definition. Sustainable architecture could be considered as an architecture that interacts strongly with the context. And it's not only the environmental context, but also the economical and the social context. And the main objective in this definition is to improve comfort, well-being, and quality of life while limiting or reducing environmental impact. And it's important in terms of building materials to think about this objective on a scale of time, but also in scale of space, not only for one room, one house, but also in a large context of the city and the global context of the planet. When we speak about grey energy and more broadly about environmental assessment, it's important to refer to the entire life cycle of building, but also of building materials. Life cycle could be considered as all the set of transformation undergone by the materials, from the extraction of raw materials to the end of life with the waste treatment of waste disposal. So we can divide the life cycle into different steps, and each step having different environmental impact. Extraction, we talk about nature of raw material, type of resource used, and also we talk about footprint. Production, what is very important, what type of raw material is used, what type and amount of energy is used to produce building materials, and also what kind of transformation undergone by the materials. The implementation on the building site, it's also important because the type of assemblage could have an influence on the recycling process. There is also an impact for workers, health impact for workers. The bigger step in the life cycle of materials is the life in use, when materials are in relation with the occupant. And the last step is the end of life. So I try to classify those environmental impacts into 5 major categories. You have the consumption of non-energy resources, raw material, water, and so on. We have the consumption of energy resources, and this is the subject for today. The environmental impact, pollution of air, water, soil, loss of biodiversity, landscape changing. The health impacts, not only for the occupant of building, but also for the workers in the building sectors. And the waste production with the great potential of recycling. In those different impacts, there is some quantitative impact and also qualitative impact. And those quantitative impacts could be assessed and calculated thanks to the life cycle analysis. Life cycle analysis is the quantification and the evaluation of some environmental impact. This kind of analysis is now regulated by a European standard since 2006. I don't want to go deeper in in the description of this analysis, but I think it's important to just give you some information about it. A life cycle analysis do not analyze a material, but the material with his function. It's very important. So we could define a functional unit and also a reference flow. What is also important for this kind of analysis is to know the limits of the study. Is it a global study all around the life cycle, or is the study just take some steps and analyze some steps of the life cycle? So on the screen you have the mandatory environmental impact, but there is also some other impacts, optional impacts, which could be also assessed. It's important to say that the life cycle analysis is not intended to cover all environmental impact, just what is quantitative could be analyzed. Now we could go to the subject of today, embodied energy and grey energy. I would like to make the difference between the two terms, because in English there is a difference. Embodied energy is the energy required for the production process of a product. It's just only for the production, as you see in the picture there. So embodied energy do not include energy requirement for transport, for implementation, for disposal of waste. And grey energy, it's a more global concept about energy used for building materials. Grey energy is the energy required for all the transformation undergone by a product throughout the life cycle. It could be divided into 5 types of energy: renewable energy and non-renewable energy, but also what we called energy materials. So this is the energy stored by the material, and this energy could be recovered. And also the energy process used for all the operation of processing, transport, and so on. There is a lot of database that gives some information about gray energy, primary energy, and so on. In Louvain-la-Neuve, in my research team, we develop a database including information on gray energy, but also other environmental impact for approximately 200 materials. What is also interesting with gray energy and energy performances in buildings is to compare energy required for heating or cooling, but in Belgium we must heating a lot. So we compare energy required for heating and gray energy required to achieve energy performance. So we made this small comparison. We try to work with different energy performance, APPD, low energy standard, passive house standard, and more efficiency standard. We compare heating energy and gray energy with different kind of structure, 2 massive structure and 2 wood structure, and also different composition of wall. We have the different the house was the base of the studies. The different walls here analyzed. We compare the 2 requirements of energy over 50 years, taking into account of average lifetime of building materials. So what could we say with the results? First, it's normal. When we try to be performance in building, we decrease the energy consumption, but we could see that there is here at the low energy standard a balance between gray energy and heating energy. And in the passive standard, gray energy becomes predominant. So when you want to decrease the operation energy in building, you have to pay attention to the choice of material and to the gray energy also. Another aspect linked with gray energy is the transportation of building materials. Transport is very important because it's the link between every step in the life cycle. The first comparison is the comparison between the various means of transport. It's clear that the air transport has a lot of environmental impact, but it's not in adequacy with building materials. But you could say, or you could see also that the van have a big environmental impact for grey energy consumption, but also global warming potential, acidification potential, and photochemical ozone formation, creation. And it's important because in the building sector we use a lot and more van to transport workers, but also to transport building materials. We could see also that train and river or sea transport have a very, very low transport, very low environmental impact. During my PhD, I tried to answer to the simple question: does local building material really limit the impact of the transport? And to answer to this question, I take 7 different distances covered by materials. And I tried just to work on this issue. So a building material is produced somewhere in the world. The material must be transported to the building site in the center of Brussels, in Belgium. We could pass by a retailer or not. I don't show you all the results. I just want to show this picture. We could see that it's normal when the distance become more and more important. The energy consumption increase, but it's not a linear increase. And we've assessed this result for 1 ton over a distance of 1 kilometer. We could see that on a long distance, the gray energy consumption is very low. And on short distance, the gray energy consumption is higher. So what is very important is not really the distance, but the means of transport used to transport building materials. This is quite the same result, but it's only a small studies for wood and with different origin, Siberia, Brazil, and Germany, with different means of transport. And what is very interesting is the low difference between wood coming from Brazil and wood coming from Germany. One is transported by sea transport, and the other is transported by truck. So, what is important for designers, for architects, is how to manage with those information, how to use it in a design project. So I just want to give you some overview about tools to help you in the project, in the design project. First one, the environmental product declaration. It's a declaration made by the manufacturer, and the objective of this declaration is to compare 2 products with the same functional unit. So you could compare 2 different tiles, concrete tile and terracotta tile. But there is a lot of good information, interesting information, not only for gray energy, but also for water consumption, waste management, and also different environmental impact like global warming potential, acidification potential, air pollution, water pollution, and so on. You could also use what I called checklist. It's book or internet link. You have the Green Guide made by the BRA in England. Some tools very interesting in Switzerland made by Ecobo. Some Dutch information, and also a very good tools. It's a Bo book in Austria. You have also software more complicated, but give you some also, those tools give you also good information, interesting information, but only on quantitative criteria: grey energy, global warming potential, acidification potential, and this is so. So English tools, Swiss tools, and also Austrian tools. And to finish my presentation, I would like to introduce more practical example. First of all, I would like to make a comparison between different blocks, concrete, terracotta, and cellular concrete. Those blocks are integrated in a wall. It's important to assess not only materials, each material by each material, but to assess a set of materials assembling in a wall. So we could also compare the physical or technical performance. So the three walls have mainly the same thermal transmission. You could see there is also different other technical aspects like thermal mass and acoustical performance. This is the result for the terracotta and the cellular concrete. I would add that there is also two layers of plaster inside and outside, and the insulation layer is the same. It's a expanded polystyrene. So we could compare the environmental performance over 50 years, and we take into account of the production of material, replacement and elimination, and we have the result on the screen. We could see that the concrete block is more interesting for grey energy and photochemical ozone, but for the global warming impact, terracotta is more interesting, and for acidification potential, the cellular concrete is more interesting. So comparison is not really easy. We could also introduce more qualitative impacts, resource depletion. So the small figure in red, it's an excellent choice. The figure in green is an excellent choice, and the figure in red is a bad choice. We could also make the same for the recycling potential. So we have a more holistic vision on the environmental impact, not only quantitative, not only energy consumption, but also other aspects, very important: recycling, health impact, resource depletion. We could make also the same for walls. Okay. I would like to compare with you massive walls, the same as before: concrete block, two-layer plaster, and insulation in mineral wool. The other wall is a wood structure, also with mineral wool and two layers of plaster. The two walls have the same thermal transmission. There is some difference in thermal mass and in the acoustical performance. You could say also there is 5 different materials in the first wall and the double in the wood structure. It's important in terms of waste disposal and waste management, and also for the recycling. This is the environmental performance over 50 years, we could see that the first wall is very interesting in terms of grey energy, but the wood structure, because of the storage of the CO2, it's very interesting also. So on two criteria, very important today, global warming potential and energy consumption is very difficult to compare. So it's important to enlarge the vision to other criteria. This is the result for the resource depletion and for the recycling potential. For the recycling potential, there is a gap of information. What exists as a potential for recycling, what are the recycling options, is not so clear for all the materials today. So, as conclusion, I would like to say to you, please expand, enlarge the criteria for the building material assessment. I think the first step for designer and for architects is rationalize and optimize the use of materials at the scale of the building. It's very, very important. And then with the same technical performance, it's important to have a consistent set of criteria, taking into account resource depletion, energy consumption, environmental impact, and health impact. So I just put on the screen the different aspects of building material and environmental impact. Thank you for your attention.
First of all, my apologies to Dr. Trachte. I forgot to introduce her to you at the beginning of her speech, so please let me say she's an architect. She has been practicing architecture in Brussels for about 10 years. She has a European Master in Architecture and Sustainable Development, and she's also a participant in various research programs. So thank you very much for your presentation. Are there any questions for Dr. Trachte?